And she's beautiful. She's recording.
Yeah, she's a great actress. Le quedó papel.
We're doing it on the
Night and day, daytime.
Since spoiler,
night and day.
since it's a stream.
So let's cross our fingers. I didn't have time yesterday to really check out the program, so let's hope that it works. We left off talking about parameters, streams as parameters, and I don't think I finished explaining that yet. Why do you need to pass parameters by reference? The reason is the following. These stream parameters, they represent a connection to a file. And as part of the connection to the file, we have the name of the file to which the connection goes, but also where in the file, if it is an input file, where in the file the next item of data will come from. If I wouldn't pass, for example, this input file stream here by reference, if I would not pass it by reference, then what would happen? I would be passing it by value. But what does that mean? It means that a fresh connection object, messy file, would be created, and in my call I would be supplying a connection object. I would be supplying an input file stream object, and that would be copied to this fresh object. And then every change that is made on behalf of this function makeNeed to that stream would be made to that copy. And when we return from that function, we would find the original object that I passed in unchanged. Let's illustrate this with two read numbers, and I pass in, let's say I've called my input file stream fin, and then read strings fin. So if the purpose of read numbers is to read a few numbers, let's say, just for the sake of example, 5 numbers, and the purpose of read string is to read 5 strings. Now, if read numbers was declared like this, void read numbers, and then if stream not by reference, if it was declared like this, not with a call by reference parameter, then what would happen? We would copy this fin to a fresh input file stream object in. We would then read inside read numbers, we would do the reading of the 5 numbers. But when we return from read numbers, when the program returns from read numbers, fin is unchanged because we did those modifications on a copy. So we would then start reading the strings at the start of the file again. It's clearly not what we want. All these operations, reading data from a file, writing data to a file, they only make sense if the stream is actually updated, if reading an item of data advances this position where in the file the next item of data would come from. Otherwise, this whole analogy of the stream breaks down. So that's the reason why when we deal with input file streams and output file streams, or actually when we deal with any streams, that we pass as arguments to a function, then the parameter always needs to be a call by reference parameter. Okay. in many cases, you will have a scenario where the file has to contain a certain number of data items. Let's say the program needs to operate on 4 values, so the file has to have 4 items of data in it. Yeah? But in other cases, you don't know beforehand how many items of data will be in the file, and your task is to work with all the items of data that are in the file. Let's say you're supposed to take the average of all the numbers that are stored in a file. What are you going to have to do? You're going to have to read one after the other of the numbers that are stored in the file, sum them up, and also count them, and finally, when there's nothing more to read, then divide the sum, the overall sum that you have produced, by the count that you counted. Easy enough. But the key here is you have to read until there's nothing more to read. How do you express that? How do you express that in C++? It turns out that what we've used up to now, this extraction here, the extraction operation does not just form a statement for us, it forms an expression. So this entire thing here, this program fragment, in stream, extract, into next, that entire thing has a value, true or false. So the result of this will be true if there was something in the file in stream, an item of data, that could be extracted and assigned to the variable next. Then the whole thing here is true. And if there was nothing more to read in the stream, in stream, then in that case the whole expression here results in false. Yeah, clear? So what that allows us to do, it allows us to write loops that are controlled by this expression. It allows us to write something like this here. This is just variable declaration and initialization. So it allows us to say while in stream extract into next do this and that. And what are we saying by that? We're saying while there is something in stream that can be extracted into next, and it also is extracted by that, while that is the case, we go into this loop body. Yeah? So while there is something that can be extracted into the variable next, and as a side effect of this expression, it is already extracted into the variable next, we do this. So we sum, in this case, we sum the next value into the overall sum, and we increment our counter. Eventually, after looping through this many, many times, I mean, presumably if the file has many, many items of data in it, eventually we reach the end of the file. What happens then? Well, there's nothing more to extract then. So this expression here becomes false. And so we don't go into the loop body again, but instead we go down here and we assign to the variable average sum divided by count. Yeah? So this is a very typical way of using this extraction operation to control the iterations of a loop. Yeah, clear? Okay. At one point in time, I told you that you should put this using namespace std at the beginning of your source code file, right after the include directives. And then we came across some slides that said that you really should better place it inside a function, only into those functions that actually make use of functions from the namespace std, that actually deal with input and output, for example. Yeah, remember? And at that point in time, I told you to take this with a grain of salt, that this is going to make matters more complicated a little later on. Well, now is that time where this would make it more complicated. Because if you, I need to go back a few slides. If you were to only put this using namespace std inside some functions, then it would only have an effect inside the function. It would only have an effect inside the function body, and not, for example, in a declaration like this one. So in this declaration, you would have to prefix ifstream with std : and same with ofstream. You would have to prefix that with std : in the long term, you will abandon this. In the long term, you will actually prefix your identifiers with std : because that's considered to be good programming practice. But for the time being, being at the beginning of all this journey, it's a good idea to try to unclutter your source code files by putting that using namespace std at the beginning, and then just having not having to prefix everything with std : Okay, and basically this is what this slide here is talking about. Okay, let's look at a program example. It's a program that illustrates the use of these formatting tools that we have discussed. Let me turn to the source code. So what do we have here? We have several include directives. We need to include IOStream, that's clear. We need it for input and C in and C out. Fstream, in order to have IFstream and OFstream available. CSTDLib, because we want to use exit. IOManip, because we are going to want to use IO manipulators. We see that on the next slide. And then we have this function makeNeat here, which takes two stream parameters. One is an input file stream, one is an output file stream. And two other parameters, number after decimal point and field width. The precondition is that the streams messy file and neat file have been connected to files using the function open. So this function expects the streams to already be opened. It doesn't open them for us. And in a similar vein, it doesn't close them for us, but this is stated in the post condition. The post condition is that the numbers in the file connected to messy file have been written to the stream and to the file connected to the stream neat file. The numbers are written one per line in fixed point notation, not in scientific notation, with number after decimal point digits after the decimal point. Each number is preceded by a plus or minus sign, and each number is in a field of width, field width. So that's the pre and post condition for the function makeNeat. Here we attempt to open the corresponding files. If we get past this without any exit, then there's this call to the function makeNeat. And what happens in here is that we set up the neat file and cout in the same way, because we want the output, the neat output, to go to standard out and also into the file. So we have to set these up in exactly the same way. I is : fixed, I is : show point, I is : show pause, and precision number after decimal point. That's from the parameter here. And do that for neat file and do that for cout. And then we have this loop, a loop in exactly the same fashion that we just discussed, that goes over all the data in messy file. So this will be true as long as there is something in messy file that can be read and extracted and assigned to the variable next. And also that happens as part of executing this. So this will be true when this can be done. And in that case, we have something in next that needs to be output. So we output it to cout, but we want to output it in a field of width, field width. So first we insert the IO manipulator setW field width, to prepare a field of that width, and then we insert next, and we have to do the same for neat file. And what will happen is that if we have an input file that contains data in all kinds of ways, I mean, here we have scientific notation, we have fixed point notation, we have many digits after the decimal point and very few. We have several items of data per line and only a single item of data in a line. We have blank lines in there. We have leading white space on that line. So it's all over the place. All that data is read by the program, and it's output like this into a file neat.dat, and this is the screen output that we will see. Okay, let me go back. So here's a little test for you. If we run this statement here, what will it output? And I'm going to give away a little of it. It starts with a star. And what comes then?
1, 2, 3. 1, 2, 4, 5.
1, 2, 3, and then?
And then another star.
Another star?
And that's the end line.
And end line.
1, 2, 3, 4, 5. End line. 4, no, 3, 4, 5 after that.
Where the 4, 5?
Right there with next to the 3.
Here?
Yeah.
Yes, yes.
Yes.
All right, because even if it has series, it has 5 digits, it continues.
Yeah.
What's the justification?
Because when you have 5 digits and you put it consider it all in a small bit, it will still produce the 5 digits. Only it's going to show you the error when it prints out.
Exactly. Exactly. Yes, very good. Okay. What about the effect of these flags? Do you think you know what IS : fixed will do?
Does it have to do with decimal points?
It does.
Yeah.
In a way it does. It has to do with scientific notation and fixed point notation. Whether you want this format, for example, 1.75 E10, or whether you want whatever, the number written out. Fixed point notation as opposed to scientific notation. Yeah, and that also explains this one. What about show point? What does the show point do? Timothy.
It allows you to decide how many numbers you want to show after a decimal point?
Not how many numbers.
Okay.
No. Not how many. Anybody? It says that you want the numbers to show a decimal point even though all the digits after the decimal point might be 0. I mean, if you have a number like 15.5, that 0.5 is going to be shown because it has a decimal. I mean, it has these digits after the decimal point. But if you have 7.0, for example, then if you don't put show point, then the 0.0 is not going to be shown.
Show point does again?
It usually shows
What I just explained. Show pause. What does that do? Forces positive numbers to have a plus sign shown. What about IS : right? And that should be IS : left there. What about those two?
It changes in the width thingy.
Yes, yes, yes. Yes, exactly.
That I know.
It changes how it is aligned in a field of a certain width. That's exactly right. Okay. So before I go on with the next topic, does anybody have any questions? Doubts? Anything we need to go over? Some more? No? Okay. So, let's talk about character I/O. Up to now, our approach to input was that we were thinking of input as inputting chunks of data, an entire chunk. So for example, when we wanted an integer, we declared an integer variable and we extracted from the input stream into that integer variable. And obviously what goes on underneath is that the user then, or from the file, there are several characters that are being read, digit characters, and they're pieced together to form a number. And that work of converting several keystrokes, either typed at the keyboard or taken from a file, to a numerical representation, that is done inside the extraction operation. It's done for us. That's this idea of the extraction operation providing chunks of data. If we have a double variable, for example, then the extraction operation can deal with scientific notation, for example. You can enter 1.75 E15 and it's going to convert that to the corresponding double value internally. That's good if what we're after is dealing with items of data, with chunks of data. But sometimes we want to deal with the text that a user enters directly. Imagine that you want to write a function that can take some input from the user and the program is supposed to capitalize. Starts of sentences. And so if this would be the input to my program with lowercase here and lowercase after a period, then we might want to write a program that capitalizes this character here and this character here. And if there would be another sentence after this one, then it also should capitalize that. But we might want to write this program in such a way that all the spacing in between here and all the new lines and everything is kept as is. So if I have several paragraphs that I entered into the program, then the output will also have several paragraphs. Right now, with the extraction operation, as we have discussed it, we have no control over whether two items of data that we read from the input are separated by a single space, by a single tab, by a new line, by several new lines, by 100 spaces, by a mix of all the above. We have no way of knowing that. Yeah? So what we're going to talk about now in this topic is how to get access to all the characters that the user entered. So we're talking about input at a lower level. When it comes down to it, really underneath it, all data is input and output as characters. Think about typing a number or a sentence or anything at the keyboard. You're striking individual keys on the keyboard. So each and every digit, for example, that makes up the number 10 is initially entered as two characters. A character that represents the digit 1 and another character that represents the digit 0. So input and output happens as individual characters, and the interpretation of 1, 0 as the number 10 or as characters depends on the context in which the input happens. If the program is waiting for a string to be entered, then the 10 that you type in is going to be treated as a string and not interpreted as a number. And if the program is waiting for an integer to be entered, then there is a conversion taking place. So that was the I/O that we've dealt with up to now, that does some internal conversions if that's necessary. So now we're going to talk about low-level character I/O. At that level, we perform just with input and output just with single characters. And they're not converted in any way. They're not interpreted any way differently. We just get the raw characters. And obviously, what this allows you to do, it allows you to devise the input in any way that you need. There's a member function called get. And that gets a single character from the input file stream, or any input stream actually, doesn't have to be an input file stream. Reads one character from an input stream, stores that character in a variable of type char, which is the single argument that you need to pass to this function get. You need to pass a variable because that variable is a call by reference, goes to a call by reference parameter. And it doesn't use the extraction operation internally, and it does not skip any blanks or anything. You get the raw input. How do you use that function? Well, any input stream, whether it is cin or whether it is an input file stream that you have connected to some external file, can be used. You have to have a character variable, and you pass that character variable to this member function get. That is a member function of any input stream. You get blank spaces, you get new lines, everything is red. You can do that like we just did on the previous slide, or you can do that with streams, with file streams like this one, that you connected to an external file called infile.dat, and then you can get characters from that stream. So here's an example that illustrates how get works differently to the extraction operation. Let's say we have three variables, C1, C2, and C3, and we have these three get member function calls. And this is the input that we're seeing from the user. So cin.getC1 gets the capital A, cin.getC2 gets the capital B, and then cin.getC3 gets the new line that is here that the user has to have entered in order for this to go to the next line. By contrast, if I would do a cin, extract into C1, extract into C2, and then extract into C3, I would get an A into C1, a B into C2, and then because extraction always skips leading white space, that new line character here would just be skipped, and I would get the C into C3. Okay, here's a little program fragment that shows how to use this in a bit larger context. It reads a line and echoes it, so prompts the user to enter a line. We have this character called symbol. We get the next character into that character variable, insert it into cout, and then we check, was this a new line that we just inserted? If it was a new line, then we're done. We have reached the end of the line and we have already inserted the new line, so there's nothing more to do. If it wasn't a \n, well, then we need to keep going, get the next character inserted into cout, and so on. Okay, yeah, this might be a bit confusing when you first run into it, but I think you all have taken a few math courses, so I'm going to explain it with something from math that I hope you're all familiar with. If I have a number 1, single number 1, and I have a set that contains a single number 1, those are two different things. The set containing a single element, namely the number 1, and the single number 1, those are two different things. One is the set and one is just a number by itself. While in a similar way, not quite exactly the same, but a string here enclosed in double quotes is a sequence of characters. That sequence can be empty, it can contain a single character, as is the case here, and it can contain several characters, a sequence of characters, a longer sequence of characters. By contrast, if I have something that is enclosed in single quotes, it can hold a single character only. It is a character literal, single character literal. So that can hold a single character only. Okay, you might say, but this \n looks like 2 characters. Yes, it looks like 2 characters, but it's just a way of writing a single character that we otherwise cannot write. It's the new line character. So it's a single character. Now, to make matters worse, if you insert this character literal consisting of only \n, or this string literal consisting of only \n, you will see the same effect happening in your output. It's going to go to the next line, whether you do that with a character literal containing a \n, or whether you do that with a string literal containing a \n. So that makes it even worse, I guess. They do have different data types. So the operations that you can perform on them will be different. We will see later that, for example, with a string literal, you can concatenate several strings, but you cannot concatenate a string and a character. Anyway, that's left for when we talk about strings. The member function get allowed us to do something that we weren't able to do before, namely get access to the exact white space, to the exact formatting, if you want, of the individual items of data that are on the input. How many spaces separate 2 words, or is there a space, a tab, and a new line or something, whatever is in between those 2 words. We were able to get at that with the get member function, and we were not able to get at that with the extraction operation. Now, the put member function is, so to speak, a dual, a complement to the get member function. It is a member function that every output stream provides, and it allows us to output a single character to the output stream. But it doesn't really allow us to do anything new. Everything that we are able to do with the put member function, we're also able to do with the insertion operator. Because when I feed, for example, a space or a tab or a new line to the insertion operation, then that happens on the output. That's not silently eaten or dropped or anything, not as is the case for the extraction operation. So, the takeaway from this is that the get member function is more important for us at this time than the put member function, because it allows us to do something that we previously weren't able to do, whereas the put member function doesn't really allow us to do anything that we weren't also able to do before. This is how you would use the put member function. You can, as an argument, you can put a single character literal, or you can put a character variable here. And in the same way, you can work with output file streams that you connect to a file yourself. You can then, as soon as you have connected the stream, you can then put a character literal or a character variable onto that stream. Any questions or doubts at this point? Okay, so here's another function. It's a rather strange function. It's called putback. So by the name, you might first be tempted to think that it is a function a member function of an output stream, because after all, put was a member function on the output streams, but it is a member function on the input streams. And it allows you to put back into the input stream, so to speak, drop back into the input stream. Think of a hot potato, you know, you pick it up and you drop it. It's not meant to be touched by you. So you put it back into the input stream. So it's a member function of every input stream, and it is useful for
Vamos a terminar en
okay. So it allows us to put back a character that we read into the input stream, and the purpose of that is so that we can write functions that keep reading until they encounter a character of which it is clear that that character is not meant for the task of this function, and then the function just puts the character back into the input under the assumption that maybe there is a later function that does need to deal with this character. Yeah? So that's the idea here. And yeah, and to make things even more confusing, I think it says that, yeah, to make things a bit more confusing, the character that is placed back into the stream doesn't even have to be the original character that was read from the stream.
So you can take it, change it, and then put it back.
You could do that, yes. Yes. You'd have to come up with a scenario in which that would actually make sense to do, but yeah, you could do that. Okay, here's an example. The purpose of this code is to read up to the first blank in the input stream fin, and to write the characters to the file connected to the output stream fout. So we attempt to get the next character. If that next character is not a space, then we output it to fout, and we get the next character. So eventually we're going to arrive at a space, let's say. I mean, that's the assumption here. We are going to arrive at a space. So this makes this condition false, and we get to this point. But the space was not meant to be consumed by this part of the code. But maybe some later part of the code relies on that space being there. So we better put it back. Yeah?
Is this like good for the example that you showed us earlier about capitalizing the words at the beginning of each sentence?
It wouldn't be needed for that, because here at that example we would have an input and an output that, and we can see that after a period that ends a sentence, we find a lowercase letter, and then we just change that lowercase letter to an uppercase letter, but we put it into the output. So we don't have to use a put back, because we're not doing anything to the input. Okay. This is about allowing the user to correct the input before actually proceeding with the value that the user has input. So we're going to allow the user, we're going to prompt the user after reading the user's input. We're going to prompt the user, we're going to tell the user, this is what was read. Is this actually what you wanted to enter? Do you want to proceed with this value? Basically, that's what we're after. Is this value correct? Yes, no. And the function that we're going to look at is called getInt. What it does is it obtains an integer value from the user, and the way it does it, it prompts the user, reads the input, and displays the input. After displaying the input, it asks the user to confirm, and this repeats until the user indicates with a capital Y or a lowercase y that the value is actually correct. Okay, so let's look at that source code. We have a function here that is called newLine, and the purpose of this function, as the comment states, is to discard all the input remaining on the current input line. It also discards the \n, the new line, at the end of the line. And why is that? Well, we're going to prompt the user by saying, is this value correct? Yes, no. And the user might just enter an n. But the user might also say, no, it is not, for example. Yeah? Or just no. And our program is going to work with only the first character. But we can't just read the first character and leave all the remaining characters in the input, because if the user said no, then our program needs to have the user enter the number again, the integer again. And we can't have the character the character O, comma, space, and so on, all those characters in the input, because an attempt to read numbers while this is all still in the input would give us a 0 and not consume any input. Okay, I'm going to get back to this in a moment. Well, I mean, if we still have that moment. Well, we won't have that moment. So what I encourage you to do over the weekend, take this source code, enter it into a file, and take out the call to the function newLine to experiment with this. Take out the function, the function call. You can actually just put a comment sign in front of it, / to comment it out, and then compile it. And then enter no it is not, and watch what the program does. And then take the comment sign out again, recompile, rerun, and enter this no it is not again, and observe the difference in the behavior. And then think about why is it behaving this way or that way, depending on the function call to newLine. Okay, that's it for today. I have office hours starting in 10 minutes, so if you care to see me, I'll be there.